On September 10, 1994, David Noble rappelled into a gorge and saw trees that should not have existed. The species had been considered extinct for millions of years. Until that moment, they were known only from fossils. Noble took a branch, and a few weeks later, botanists confirmed he had found an unknown genus that had existed for over 200 million years. The garden's director called it the discovery of a living dinosaur. The species was named Wollemi nobilis. And then the Australian authorities did something unusual. They classified the coordinates. Why? Genetic analysis revealed something botanists hadn't expected. All the trees in the grove are effectively clones of one another. Somewhere between 10,000 and 26,000 years ago, the population passed through a catastrophic bottleneck. Perhaps one or two individuals survived the Ice Age. All genetic diversity disappeared with them. 89 trees, nearly identical DNA in every one. If a disease appears for which there is no natural immunity, it could kill them all, simultaneously, with no chance that even one survives. The first alarm came before any disease appeared at all. During one of the first scientific expeditions after the discovery, the rotor blades of a helicopter caught the crown of one of the trees. No malice, just a narrow canyon and a careless maneuver by a pilot who didn't know exactly where he could hover. The tree survived, but it was the first proof that people with the best intentions can cause damage simply by being present. Access was restricted as a result. The number of visits was reduced to a minimum, though even that turned out not to be enough. In 2005, scientists came for a routine check and saw something that shouldn't have been there: yellowing leaves, crown thinning in several trees. Analysis confirmed it: Phytophthora cinnamomi. In Australia, it's called the biological bulldozer. The pathogen attacks the root system, gradually cutting the tree off from water and nutrients. There is no specific treatment. And the key point: a single gram of infected soil on the sole of a boot is enough to trigger a chain reaction throughout the entire grove. Someone had brought the pathogen in from outside, simply a person from a different microbiome, with no malicious intent whatsoever. In a grove where all 89 trees are genetically identical, there is no natural buffer. Not one tree that might prove resistant and slow the spread. A well-meaning visitor in this context is the same vector of threat as a deliberate poacher. The difference is only in intent. The outcome is identical. It was after this that secrecy stopped being an administrative decision and became a question of the species' survival. Now boot soles are washed with methylated spirits before entry into the canyon. Some researchers are transported by helicopter blindfolded, so they cannot memorize landmarks and return independently. The fine for attempting to find the grove is $300,000 and 2 years in prison. The requirement is simple. Even those who know where the grove is must not have the physical ability to find it unescorted. Wollemi nobilis is not the first or only living fossil tree that humanity has had to protect after its discovery. 3 other cases show why the Australian strategy is in a category of its own, and what happens when you choose a different approach. In 1943, Chinese forester Zhan Wang found trees in a valley in Hubei province that science didn't recognize: Metasequoia glyptostroboides, a living copy of a genus known only from Mesozoic fossils. Local residents had long built an altar near the oldest tree in the village of Modaoxi and brought offerings to it. When scientific identification confirmed the find, China classified nothing. In 1948, the Arnold Arboretum at Harvard sent an expedition for seeds. Today, that same tree in Modaoxi stands enclosed by a decorative fence and is a tourist attraction. No fine for visiting. But what the Chinese failed to protect nearly disappeared. After the 1949 revolution, a significant portion of the population in the Shaohei River Valley was logged. The oldest trees went for timber and fuel. The central population numbered around 6,000 large trees before the revolution. After 1949, much of it was destroyed. The species survived not because the site was protected, but because seeds had already spread to botanical gardens around the world. Harvard had collected them in 1948, 1 year before the logging began. 1 year between salvation and loss. In Australia, that lesson was absorbed and inverted. Propagate first, then open the market, and never reveal the location. The difference between the Chinese and Australian approaches is in the numbers. Meta sequoia in the wild, thousands of trees in several valleys, genetically diverse. Even mass logging couldn't destroy the species entirely. Wollemi, 89 individuals, one canyon, cloned genetics, a pathogen in the soil. There is no margin for error. The American experience adds 2 more variations, and neither ends well. In 2006, naturalists Chris Atkins and Michael Taylor found a tree in California measuring 115.6 meters, the tallest living organism on Earth. They named it Hyperion. The coordinates were not released, but bloggers and YouTubers found the approximate location themselves through public photographs, geotags, and trail descriptions. Within a few years, the forest around it had been trampled into a network of informal paths, the ferns at its base destroyed, the roots damaged. In 2022, the park closed the area. A $5,000 fine and 6 months in prison. Secrecy didn't work. Fame proved stronger than the absence of marks on a map. Methuselah, a bristlecone pine in the White Mountains, 4,857 years old, the oldest living organism on the planet that is not a clone. Here the strategy is different. Not to hide the location, but to hide the specific tree within an open location. Tourists walk past it every day along a 7-kilometer trail and don't know which one it is. Rangers don't point it out. The strategy holds, but for one specific reason. Physical contact by thousands of people with a bristlecone pine poses no threat to the species. At Wollemi, none of those conditions apply. One careless visit, and the difference between these strategies becomes the difference between a species and a fossil. Secrecy solves the problem of deliberate access, but it doesn't solve the problem of the black market. As long as the species is legally unavailable, it is worth a fortune to collectors. The answer came counterintuitively: flood the market. But first, they had to learn to grow a tree that had never been grown before. Shortly after the discovery, the Wollemi Pine Recovery Group was formed. Botanists, rangers, fire management specialists. Kathy Offord from the Australian Botanic Garden, Mount Annan, was given a specific task: figure out how to propagate something no one had ever cultivated. The task sounded simple. In practice, it turned out otherwise. The first problem was seed. Of all the seed the trees produced, only about 10% was viable, and a quarter of that was damaged by animals before collection. What remained had to be gathered in a secret canyon where every additional expedition was itself a risk. Even under greenhouse conditions, the seed germinated slowly, roughly 4% per week, and getting a reasonably reliable result meant waiting 6 months. For a species where the count was in the dozens of trees, this was too slow and too unpredictable a path. Offord moved to cuttings. But here too, everything started from zero. Of all methods, seed, cuttings, tissue culture, cuttings from orthotropic shoots proved most promising. The problem was that nobody knew the precise parameters: what temperature, what humidity, which shoots to take, vertical or lateral. They worked it out by trial and error. Cuttings 10 to 15 centimeters long were placed in a perlite and peat mixture, maintained at no less than 75% humidity with soil heating to 25 degrees, and checked after 8 weeks. But the key discovery came unexpectedly. Rooting hormones, standard practice for conifers, had no effect at all. Wollemi rooted on its own, without chemical assistance, if the conditions were precise. This contradicted everything known about related species. There was almost no room for mistakes. Every cutting from the wild population was a fragment of a tree that had survived 2 million years and might not survive the next season. The first ex situ collection was established in Sydney in 1996 to 1997, seed and cuttings directly from the canyon. Then, once the protocol had finally stabilized, most of the collection was transferred to Queensland for commercial propagation. The final result: rooting success of 90% and above. From complete unknowing to a reproducible industrial process in 7 years. By 1999, the Queensland Forestry Research Institute together with Birkdale Nursery had received a commercial propagation license, and the first 500 plants were transferred to them from the Royal Botanic Garden, Sydney. By 2003, the first saplings were ready for auction. David Noble, by that point, had lived with the secret for 9 years. The field officer who had rappelled into the canyon in 1994 had in that time completed a degree in applied science and been promoted to ranger. The man who had named over 200 remote features in the Wollemi wilderness, canyons, cliffs, and depressions, now could not name even the most important coordinate he knew. The species had received his name, Wollemi nobilis, but the place where he had found it remained a state secret and for him had become an ever greater responsibility. On October 23, 2005, Sotheby's held what it called the botanical sale of the century on a lawn beside the herbarium of the Royal Botanic Garden, Sydney. Over 400 people under and around a marquee. Phone bids from around the world. 292 saplings ranging from 70 centimeters to 2.25 meters in height in 148 lots. Each tree came with a certificate of authenticity. Which of the 15 wild trees the cutting had been taken from, the height and girth of the parent tree, the number of main trunks. The buyer knew the lineage of their sapling, but did not know and would never know where its parent tree stood in that gorge. American collectors could not participate in the auction at all because import regulations prohibited bringing in live plants of this type. The location remained closed even in the auction documents. Bidding closed in 3 hours. Not a single lot went unsold. At Sotheby's, this is called a white glove sale. The total, 1.59 million Australian dollars, twice the most optimistic forecast. A lot of 15 saplings went for $150,000. The average price per plant, $3,600. All proceeds went directly to the Wild Population Conservation Fund. The tree was literally paying for its own protection. In April 2006, saplings appeared in garden centers. The price, $50 to $100. What a year earlier had been the rarest tree on the planet was now growing in backyards from Sydney to Seattle. 50,000 plants sold in the first year. The black market disappeared, not through policing, but through the basic economics of scarcity. The scale of distribution exceeded any initial plans. According to a survey of over 1,500 owners in 31 countries, Wollemi nobilis in cultivation proved far more adaptable than expected. It tolerates temperatures from -5 to +45 degrees Celsius and grows across a wide range of soil types. One owner in France recorded a height of over 8 meters in 14 years. Gardens in Scotland confirmed survival at -12 degrees Celsius. This data showed exactly where reserve populations could be established in the wild. Citizens with spades and watering cans had inadvertently become the largest scientific database on growing the species in the history of botany. Why risk a fine of $300,000 and 2 years in prison when the tree costs $100 at the nearest garden center? The location remained closed. The species became global. These are different things, and the Australian strategy kept them separate with absolute precision. In December 2019, anyone could open a fire map and see. Fire was heading directly into the area of the park where the coordinates showed nothing. The maps were public. Anyone could look at the direction of the fire and understand. The grove was standing directly in its path. The question was not whether the fire would reach the canyon. The question was whether there was anything that could be done when the fire was heading for a place that officially did not exist on public maps. The Gospers Mountain fire had been burning since October 2019. Over 2 months, it consumed more than 500,000 hectares of Wollemi National Park, 90% of its total area. It could not be stopped. All that could be attempted was to protect what stood in its path. The operation was conducted in 2 stages. Both remained classified even while they were underway because the coordinates of the rescue mission were the same as the coordinates of the grove. A week before the fire closed in, specialist firefighters from the National Park Service were rappelled into the canyon from helicopters. Landing there is impossible. That was the only way in. They installed an irrigation system and pumps drawing water from the gorge's own springs. Every participant signed a non-disclosure agreement on the coordinates. After the system was installed, they were lifted back out. Air tankers treated the approaches with fire retardant. When the fire came right up to the edge, the firefighters were lowered back down. To operate the irrigation manually, helicopters dropped water on the fire's edges to reduce the intensity of burning immediately adjacent to the trees. Environment Minister Matt Keane described it in a single sentence. It was a military-style operation. We just had to do everything. Then the fire passed and silence fell. 4 days. Smoke so thick that no aerial photography could show anything. No communication with the canyon. Whether the irrigation had worked, unknown. Whether the air tankers had arrived in time, unknown. Whether there was anything left to save, also unknown. Keane told journalists, "We were just waiting with bated breath." On January 15, 2020, a helicopter was finally able to fly over the canyon. The trees were standing. Not all of them. 2 young trees had died. Most of the large ones had partial burn damage. 4 had no damage at all. But the grove existed. The species had been preserved. Keane says these trees survived the dinosaurs. When we saw the fire was coming, we knew we had to do everything possible. The operation remained secret until that announcement. Even the Victory could not reveal the coordinates. After the 2020 fire, it became clear that a single grove was too small a stake. In 2022, the Royal Botanic Garden Sydney sent 174 young trees to the United Kingdom. Not simply saplings, a collection representing all 6 genetic strains identified in the wild population. Forestry England received them at the Bedgebury Nursery in Kent and distributed them across 28 botanical gardens in the United Kingdom and Europe. Others went to 5 Australian gardens and 1 in Atlanta. The locations were chosen not for where the climate is suitable today, but where the microclimate will be suitable in 50 years. In 2024, this officially became a meta-collection under the auspices of Botanic Gardens Conservation International, the only distributed collection that preserves the complete genetic diversity of the species in the event something happens to the original grove. But here is a question the official documents sidestep. If the grove is destroyed, can the population be restored to the wild? Experimental translocations have already been conducted. 2 years after the first attempt, 85% of transplanted plants had survived, but the optimal conditions for reintroduction have not been established. In cultivation, the trees grow up to 30 centimeters per year. In the wild, 1 to 2 centimeters. An organism grown in a nursery and an organism grown in a canyon have different resilience to different conditions. The meta-collection preserves the genetics, but whether it preserves the capacity to survive specifically there, in the only microclimate where this species existed for 200 million years, is unknown. As of March 27, 2025, the date the new species recovery plan came into force, the wild population consists of 45 mature trees and 46 juvenile individuals. Phytophthora is still present in the soil. Infected trees receive regular phosphite injections. There is no cure, and there never has been. Secrecy justified itself. Against boot soles and smugglers, it held. The auction destroyed the black market. The 2019 fire operation saved the trees from a specific fire. The meta-collection created a genetic backup on 5 continents. But the Australian government in its official documents explicitly names the primary long-term threat as the increased frequency of extreme droughts and fires caused by climate change. The microclimate of a moist sandstone gorge is the sole reason Wollemi nobilis survived 2 million years. If it changes, no irrigation system and no helicopter will compensate for a structural shift in temperature and humidity. And that shift does not stop at the boundary of a nature reserve. 45 mature trees, 1 canyon, identical DNA, a pathogen in the soil, a meta-collection across 34 institutions as the only insurance. And a question without an answer: what exactly does the secret protect against? And is it enough when the threat leaves no traces on the soles of boots?